Welcome to Romeo Maths and Science class. Today we want to look at how we can solve these questions on the board under the topic power in physics. Alright, before we look at these questions, first of all, let us look at some mathematical formulas that we can use under power. Now, from the definition of power, where we said power is the rate at which work is done. Mathematically, power is equal to work done divided by time, as we can see on the board. All right. So we use this as initials to represent them. So we can say P should be equal to W divided by T. All right. Now, there are some instances where they can give you power, give you time, and you may be asked to look for work done. Therefore, we can say work done should be equal to power times time. And also, time will be equal to, that is work done divided by power. So we can have these formulas here. Now, we can have some instances where in the question, work done will not be given to us. So we need to know that work done can also be given as force times distance. All right? Or where the distance is, sometimes we can use height to represent it. So force times height, as you can see here. So in that case, we can deduce another formula for power as force times distance all over what? Time taken, as we can see. Or we can also say power should be equal to force times height all over what? Time, as we can see. And here too, you may be asked to find the force when power, time, and distance are given. Then you make force the subject. You can make distance the subject or time the subject. The same thing you can also do here. All right. We can have some instances also where our work done, all right, will be given as we have force times distance here. Sometimes the force will not be given to us, but we can break the force as mass times acceleration due to gravity. All right. Or the same force can also be given as mass times acceleration. That is A. The G and the A are different things. All right. The G is gravity and is constant. So if work done is equal to force times distance, and force can be given as what? That is mg. Then we can also say work done can be given as mass times gravity times distance. All right. Or we can say work done can be also equal to mass times acceleration times what? Distance. Therefore, we can also say power should be equal to mass times gravity times distance all over what? Time, as we can see here. Or we can also say power should be equal to mass times acceleration times distance all over what? Time, as we can see. Where the D is, we can also use H to represent it. So we can also say power should be equal to mass times gravity times height all over what? Distance, as we can see here. All right, let us look at the unit in which these things are measured in. Now, our power is measured in watt, all right? Watt into bracket capital W. And our work done is measured in joules, that is capital J. And our force is measured in Newton, all right? And our distance is measured in meters. And our mass is measured in kilogram. So these are standard units. And the time also is measured in seconds, all right? So these are standard units that we can use to measure these quantities here. Now, let us not forget some conversions here. Sometimes our mass can be given in gram, and we may be asked to change it to what? Kilogram. So we say 1 kilogram is equal to 1,000 gram. All right. And with the distance also, that is 1 meters should be equal to 100 centimeters. And our time, we can say 1 minute. All right. 1 minute is equal to 60 seconds. And also 1 hour, all right, is equal to 3,600 seconds. So these are some units that we can use to change our quantities when we need to use any of them. All right, let us see how we can apply this formula to solve our question 1. From question 1, you see that the mass of the body is given. So we have the mass of the body, which is M, and that is 3.0 kilogram. Again, when we read the question, we also have the acceleration. And this acceleration on the board is different from acceleration due to gravity. So acceleration, which is A, and that is 15, all right, meters per second square. Now, don't forget, the gravity here is constant and it's different from the A, all right? So in cases where they don't give us, we can say gravity will be given at 9.89 meters per second square, or approximately 10 meters per second square. So anytime we want to use it and it's not given, we can use it. And it's different from acceleration, so we need to know the difference. All right, so let us proceed. Again, in the question, distance is given to us. So our distance is given D, and that is 20 meters. And time is given to us. So our time, that is 5 seconds. And we have been asked to calculate power. Now, from the formulas we studied, we know that power is equal to work done over time. But when we look into the data, work done is not there. But we know that our work done can also be given as mass times acceleration times distance. All right? Therefore, our power can be written as mass times acceleration times distance all over time. So we are going to use this formula to get our power. So our mass is 3, our acceleration is 15, and our distance is 20, all divided by 5. All right? And when we multiply this, we are going to get, that is 900 divided by 5. All right? And when we divide this, we are going to have 180 watts, as we can see here. So this is how we can use these formulas to answer question number 1. Try question number 2 and number 3 and leave your answer in the comment section. Thank you.